This is the final video in agent harnessing, so let's zoom out and connect the platform idea behind the whole series. I'm Mehrdad, and our closing idea is that the harness eventually stops looking like glue code around a model. At production scale, it becomes a product that teams operate, version, and continuously improve. We'll separate the harness from the control plane, examine what survives model changes, and close with 3 principles for reliable systems. Your first agent's harness often begins as a script connecting a model to tools, memory, and an execution loop. That description works while one person owns one agent and can still understand every dependency from memory. Now imagine 10 production agents across several teams, sharing data, permissions, tools, budgets, and operational rules. The surrounding software becomes a common layer, so one informal change can affect systems across the organization. This is no longer disposable glue, it's infrastructure you must version, observe, secure, and own. The mature harness becomes a platform, not a throwaway wrapper around an interchangeable model call. For one agent, it acts like an operating system around the model, coordinating loops, tools, memory, context, and verification. Across many agents, another layer emerges above those harnesses to standardize shared services and organizational rules. That upper layer is the control plane. The harness remains tuned to one agent, while the control plane makes a diverse fleet manageable. The same model inside 2 different harnesses can produce agents with noticeably different capability and reliability. One interface encourages clean actions, while another creates formatting errors, wasted turns, and fragile recovery behavior. Frontier teams therefore retune the surrounding system whenever they ship a model, even when high-level abstractions remain unchanged. One model may prefer patch-style file edits, while another responds more reliably to exact string replacement. The model is the engine, but the harness is the car designed around it. Changing engines can require rebuilding important parts of that car. This diagram gives us the clean boundary between a harness and a control plane. At the bottom, each agent combines a model with its own tuned loop, tools, memory, and task-specific behavior. Those agents may use different models, frameworks, and conventions because each harness serves one job. The control plane applies organization-wide services without forcing every team to adopt the same internal design. It standardizes identity, policy, observability, audit, and cost across the fleet. A harness runs one agent, while a control plane keeps every agent governable. A production organization usually needs both layers. The control plane becomes concrete through services that teams should not rebuild separately inside every agent. Identity establishes who is acting and which resources that agent may use, while policy enforces common boundaries before actions execute. Observability provides one place to trace behavior, attribute failures, and preserve an audit trail across the fleet. Cost controls apply budgets and caps across the organization instead of hiding spend inside separate scripts. These are familiar harness components promoted from one agent to many, where consistency becomes an operational requirement. There is one important caveat, especially after our discussion of trained harnesses in the previous video. This platform is model relative and time-bound because some scaffolding only compensates for limitations in today's models. As training absorbs better tool use, planning, and recovery, parts of the current harness will shrink or disappear. The answer isn't avoiding platform engineering, it's designing the platform for replacement and continuous retuning. Invest deeply in durable tools, data boundaries, evaluation sets, governance, and the operational knowledge needed when models change. This brings us back to the sentence connecting every video in the series. The model supplies intelligence through reasoning, generation, and the ability to choose among possible actions. The harness turns that intelligence into behavior that is dependable, safe, observable, bounded, and recoverable under real operating conditions. The harness is where reliability lives. As agents and interactions multiply, that surrounding layer becomes most of the system we actually design and operate. The full course now fits into one map. Parts 1 and 2 established model plus harness, the agentic loop, multi-agent trade-offs, topologies, orchestration, and communication. Part 3 opened the harness and examined context, memory, tools, skills, verification, guardrails, observability, and governance. Parts 4 through 6 covered evaluation, cost, code-driven loops, self-evolving systems, trained behavior, and finally, the platform view. 21 videos explored one idea across many scales. Reliable agents emerge from the system around the model, not model capability alone. If the tools and frameworks change, keep these 3 principles from the course. First, choose path over output. Evaluate the complete trajectory, because a plausible answer can hide a fragile or unsafe process. Second, choose distributions over one number. Agents are stochastic, so one successful run or failed demo proves very little. Third, choose causality over blame. Trace failure to its decisive step in origin, not where the damage became visible. Path, distributions, and causality remain durable habits, even after today's harness has been replaced. Thank you for watching the whole agent harnessing series and for following this idea from the first model call to the platform. For a deeper treatment of evaluation, the full multi-agent evaluation series picks up where video 16 left off. Subscribe to Multi-Agent Academy for that series and future work, and connect with me on LinkedIn to continue the conversation. This is the end of agent harnessing, and that's the harness. Now go build one, and make the system around the model worthy of the intelligence inside it.